A lightweight bouncy ball with a mass of 10 grams and a heavier bouncy ball with a mass of 82 grams were observed throughout this experiment to test Newton's second law of motion and the concept of free fall. In order to solve for their accelerations, we use the formula A equals F divided by m. The variables considered to test their accelerations were dropping both balls from different heights and using the same force with the same height in order to see which ball hit the ground first.
To run our experiment and be able to understand the results, it is important that we understand a few basic physics concepts, including Newton's second law. First, it is important to note that all objects in freefall motion have a vertical acceleration equal to negative g. Negative g represents the freefall acceleration for objects on Earth, and its value is negative 9.8 meters per second squared. This means regardless of mass, objects in freefall have the same acceleration. We can further develop this idea because we know the only force an object experiences in freefall is its weight, which is the downward pull of gravity. Thus we say weight equals mass times freefall acceleration, or the constant g. This can then be related back to Newton's second law, force equals mass times acceleration, and set equal to the weight equals mass times g equation. This makes sense because it was already determined that the only force acting on the object in freefall is its weight force, and freefall acceleration is a constant, so we can conclude these equations are equal in terms of free-falling objects.
The 10-gram ball was dropped from the same height 4 times, and the average acceleration was found using a video analysis system. The 82-gram bouncy ball was then dropped at the same height the lighter ball was dropped from, and using the same system, the average acceleration was found. The balls were then dropped at different heights to display how when objects enter freefall, the acceleration, no matter the mass, is always approximately 9.8 meters per second squared. The heavier ball was then dropped from a height of 78.2 inches. Once the heavier ball had reached the same height as the lighter ball was dropped at 46.7 inches. This was done 4 times, and using the video analysis system, it was then determined which ball arrived at the floor first, or if they landed at the same time.
Through our experiment, we found that the objects had the same acceleration because they do not experience significant drag, with both balls having the same acceleration despite their differences in mass. The earlier stated concepts of freefall and Newton's second law were proven to be correct. However, due to human error, the 2 balls did not reach the ground at the same time, since we did not drop them at the same height and at the same time, even though they had the same freefall acceleration. This is not the desired experiment, and further testing is needed to display this concept of freefall properly.